The second part of lesson 2.5 still has us completing the square. But now the a value, that number that's in front of our quadratic term, is going to be a number that's different from 1. Most of our steps stay the same, but I've highlighted a couple of key changes. Step 1, set the equation equal to 0 and move the c value to the other side. We've done that before. The new part in step 1 is now we're going to factor a out of both of the terms on the quadratic side. Once we do that, we're going to have a parenthesis, and inside that parenthesis, we'll take half of the b value and square that number. So those are things that we did in day 1. Then we'll add it to the quadratic. We'll add it to the inside of that parenthesis. The change now in step 4 is we'll multiply that number by a, and that's what we add to the other side. Then we have our perfect trinomial square, and our last step will be to factor that. Make sure to have all of these things written down before we do the example on the right. Example 1D. Convert 4x squared plus 24x plus 10 to a times x minus p squared equals q by completing the square. So this is a version of vertex form for a quadratic function. And this is standard form. So we're just converting from standard form to a version of vertex form by completing the square. Let's follow our 5 key steps. Step 1, we'll set the equation equal to 0. And then we'll move c to the other side. So we'll just subtract. That gives us 4x squared plus 24x on the left and negative 10 on the right. Now, step 2 says to factor a out of both terms. That means whatever that number is, whether it goes into both of those terms or not, has to be factored out. If we factor out a 4 from both terms, 4 goes into x, or 4x squared, we'd have x squared left over, and 4 goes into 24 6 times, so we would have 6x left over. And that's the new part of step 1. Now on the inside, we have x squared plus 6x. Step 2 then, we'll take half of 6, our new b value, which is 3. Step 3, we'll square that, and we get 9. Step 4, we add 9 to the inside of that quadratic. That will make it a perfect trinomial square. We still have our 4 out in front, and we have x squared plus 6x, and now we'll add 9. But notice we're only adding that to the inside of the parenthesis. It says multiply by a to figure out what to add to the other side. Now remember, a was 4. If we multiply 4 times 9, we get 36. And that's what we're going to add to the other side. So we had negative 10, and now we're going to add 36 to that instead of the 9. From here, it says factor the perfect trinomial square. We'll leave the 4 out in front, and we need to factor two numbers that multiply to get that 9, but add to get the b value of 6 in the middle are positive 3 and positive 3. That would be x plus 3 and x plus 3. And if you remember from day 1, that's always the same answer that's in step 2 up above. On the right, negative 10 plus 36 is 26. Last but not least, we write these two as a perfect square, and we get 4 times x plus 3 squared equals, oh hi, that was my cat Diesel, sorry, equals 26. That's converting with an a value that isn't 1, from standard form to a version of vertex form. Our final 2 questions ask us to rewrite each equation in vertex form. Determine if it has a maximum or a minimum, and then state that value. To rewrite in vertex form, we'll use the method of complete the square. Let's start with y equals 3x squared minus 9x minus 14. The first thing we're going to do is set the equation equal to 0, and move the c value to the other side. We'll move 14 over by adding. We get 3x squared minus 9x equals 14. And now we have to factor the a value out. We have to factor 3 out of both terms. If we factor 3 out of 3x squared minus 9x, we would have x squared minus 3x, and then 14. So now look what b equals. b is negative 3. In step 2, when we take half of b, we're going to have a fraction, negative 3 halves. That'll make things interesting. Step 3, we'll square that, negative 3 halves. When you square a negative number, you get a positive answer. And when you square a fraction, we simply square the top and the bottom. 3 squared on the top is 9. 2 squared on the bottom would equal 4. Now add that to the inside. And remember, we have that 3 out in front, so we need to keep that out in front. And if we have x squared minus 3x, and then we're going to add that 9/4, that creates that perfect trinomial square. But the 3 on the outside is going to make things interesting for the right. If we take 3 times 9/4, when you multiply a whole number by a fraction, make the whole number a fraction and just multiply straight across. 3 times 9 is 27/4. That's what we'll add to the right-hand side. And we're going to have to deal with adding that fraction to that whole number. All right, so now what we can do is factor the perfect square trinomial on the left. That's our step 5. Here's what the unique thing is about this. Remember, we've talked about how step 2 can be helpful. If you want to try to factor 9/4 into two numbers that would multiply, or that would add to get negative 3 in the middle, we don't even have to worry about what that is. Our answer will always be this step up above, in step 2. So that number is going to be what goes on the inside. Oops, I didn't mean to make that highlighted, although it's pretty. All right, here we go. X minus 3 halves and x minus 3 halves. If you were to FOIL those two parentheses, you would in fact get x squared minus 3x plus 9/4. On the right, we have a little bit of work to do. We need to make a common denominator in order to properly add these two together. A common denominator of 1 and 4 would simply be 4. Therefore, 14 over 1 becomes 56 over 4. And if we add 27/4 to that, we'll be in good shape. All right, last but not least, on the left, we'll write as a perfect square 3 times x minus 3 halves squared. On the right, if we add our numerators together, 56 plus 27 is 83. And that gives us 83/4. Now this isn't totally vertex form, but we're getting there. We're super close. All we need to do now is move that 83/4 to the other side. And we would get in equation form y equals 3 times x minus 3 halves squared. Oh, that's 3 halves. Let's make sure that looks better. Sorry about that. Here we go. That's a little better. And then minus 83/4. There's our equation in vertex form. And then we were asked to find a maximum or a minimum. To find the max or min, we always look at our a value. And in this case, our a value is 3, but more specifically, it's positive. That means we're going to have a minimum. The arrows would open up, meaning the minimum would be the lowest point on that quadratic function. The minimum or maximum is always found at the vertex, and the value is always the k in the hk. So the minimum is at negative 83/4. That was quite a problem. We have one more over on the right. We have the equation in standard form, y equals negative 2x squared plus 10x plus 1. And we're asked to convert to vertex form and determine if this has a maximum or minimum and what that value is. All right, so let's start with our key steps. The first thing we'll do is set the equation equal to 0. And we'll move the constant to the other side. And now look what we have to factor. Not only does a not equal 1, but a equals negative 2. That's what we have to factor out of both parts on the inside for our quadratic function. If we take negative 2 out of negative 2x squared, we get just x squared. And that's what we want on the inside. However, if we take negative 2 out of positive 10, we get negative 5x. So be careful when you factor out a negative. It'll switch the sign of the b value and change the number for the b value on the inside. Oh boy, and we have negative 1 on the right. So there's our step 1. Step 2, take half of b. b is now negative 5. If we take half of negative 5, we're just going to multiply straight across. That's negative 5 halves. Make that 5 a little clearer. Maybe. There we go. Maybe. All right. So then what we're going to do with that negative fraction is square it. Negative 5 halves squared. Again, like the last time, we'll square the top, square the bottom, and we're going to get positive 25 fourths. So far, not too bad. Step 4. Remember, we have that negative 2 out in front, and we have x squared minus 5x, and then we're going to add our squared value up above, 25 fourths on the inside. Keeping in mind that that a value needs to be multiplied to that value we just calculated, if we take negative 2 times 25 fourths, again, we'll put that over 1 and just multiply straight across, we would get negative 50 over 4, but that can reduce to negative 25 halves. And that's what we add to the other side. So we already have negative 1, but now we're going to subtract 25 halves. I know it's a lot of negatives and a lot of fractions, but we've done so much work with fractions already this semester, this shouldn't be so bad. All right, step 5, we'll continue on so that we can finish. We still have that negative 2 out in front, but remember to factor here, try not to let that fraction fool you. The number comes from the value or the answer we got in step 2. X squared will split apart into x times x. Negative 5 halves times negative 5 halves would be positive 25 fourths. Negative 5 halves plus another negative 5 halves would simplify to negative 5 when we're done. On the right, we need a common denominator of 1 and 2. That's not so bad. It would just be negative 2 over 2. And then if we subtract 25 halves from that, we'll get our value on the right. On the left, let's write x minus 5 halves as a perfect square. On the right, negative 2 minus 25 would be negative 27 halves. Oh, maybe. All right. I don't know why my numbers aren't coming out so well. There we go. That's a little bit better. All right, and then we want to convert this to vertex form. So again, it was y equals. To get vertex form, we're just going to move 27 halves over by adding. I'm going to give myself a little bit more room on my screen. There we go. Hopefully you guys still have enough room to write. And we would get y equals negative 2 times x minus 5 halves squared plus 27 halves. That would be our answer in vertex form. And now to finish the problem, it said, do we have a maximum or a minimum? Well, here's where we check that a value. A is negative 2, which means the parabola has arrows at the bottom of the graph, and that also means we're going to have a maximum. Because of that negative, we know that the vertex will be at the top. The vertex is always the ordered pair, but the maximum value is just the value of the y-coordinate in the vertex, 27/2. And there's completing the square when your a value is a number other than 1.